Good afternoon, students. It's me, Mrs. Carbajal. I'm just going to give you guys a quick review what you should be studying for your unit assessment test. Okay, you're going to be studying Chapter 14, Chapter 15, Chapter 16. This is stuff we've been doing for the past month and a half now. So you should be pretty well versed in this. And all you need to do is really go over the concepts. So let me go over the concepts with you guys, all right? So we're going to, you have to remember about Rutherford. You're going to go in your textbook, and here's what I would do. I start going through the concepts and look at the question. So it says, explain why Rutherford assumed most of the atom to be empty space. Then you have to think about it. Rutherford did the gold foil experiment. Do you remember what happened when he did the gold foil experiment? Okay, so you're going to think about that. Go back to your textbook, read it, write it on a flashcard if you need to get the concept. Add it to your notes. Reading only does not help you learn a concept. What you're going to have to do, if you still don't know it, talk to your parents. Let your parents know about it. Talk to a friend. Explain it to each other on FaceTime. You guys know how to FaceTime each other. All right. You should remember about Rutherford's model, how it was different from J.J. Thomson. I gave you guys notes on that. Remember Rutherford, I always talk to you guys about empty space. There's a lot of empty space between the nucleus and the electrons. Okay. You need to know on number 5, it asks you about the strong forces of nature. You should know strong nuclear force, the electric force, a weak force, and gravity. All right, you need to know what they are and their definitions of each one. The next question says, explain the effect of electromagnetic and strong forces on the structure of the atom. Okay, you got to remember that electromagnetic forces, electric forces, are the forces of the attraction between the proton and the electrons. They keep the electrons from just jumping away from the atom. The strong nuclear force, okay, remember, is among the particles inside that nucleus. So the word nuclear, nucleus. Another one is these strong forces are held together in the nucleus, and they're overcome only by electromagnetic forces of repulsion between the protons. Okay, protons have like charges. You got to remember that. All right, next you have to know about the atomic number, what that represents. You should know about the radioactive decay, especially alpha. Remember, Ms. Carbajal says a little less, so two protons are ejected, 2 neutrons are ejected. Beta, remember the neutron, Ms. Carbajal says it's a little bit bigger. So remember, beta, bigger. So the neutron splits and it creates 1 proton and 1 electron. Which particle in the atom is most responsible for its chemical properties? I've been going over and over and over this. You should know this. Let's see. The spectroscope, that's the spectrum I talked to you guys about. And I talked to you guys about fireworks and how elements have certain colors in and they're released. So you need to know that. The spectroscope, you remember seeing it in the book, the lines of color, all right? That separates the light into the spectrum. Let's see what else. Then the next one is the uncertainty principle. You have to remember, where is it? You never know where that electron is going to be. That should help you. Go back to your notes and review it. Let me see. That is the subatomic particle's position. You have to remember, it's never the same. You're thinking of momentum, you're thinking of energy, you are thinking about the time. It's never known all at once. Then the next one is the cloud. It's talking to you, number 20, it's talking to you about the cloud. How is the location of an electron described? Well, now we think of our cloud model of what the atom looks like. All right, so that's those. Go through each one of those. If you do not understand it, you have to reread it, write it down. Let your parents know what you're learning. Talk to them about it. That helps you understand it. Okay, elements and the periodic table. You should know this by heart. I am giving you another periodic table. You are not using the same one. So remember, periods are in your rows, your groups are up and down. You should be able to tell me the properties, if it's a property, a physical property or a chemical property. You need to know about melting, boiling, and bending, that those are all physical properties, and why burning is a chemical change. How may a substance be tested to determine whether or not it is an element? Okay, you should know that. That should be in your notes. You could test it by breaking it down, and if it can't be broken down, then it's an element. How many elements are there naturally occurring? 92. The other ones are, all right, that's pretty easy for you guys. All right, let's go on to the next one. The period in a group I already told you about. What property of elements was used to organize the periodic table? Okay, remember, groups are alike. And how is it put together on the periodic table? The periodic table, remember, has an atomic number. What does the atomic number represent? The atomic number represents the number of protons in the periodic table. If it's a neutral atom, the protons equal the number of electrons. Next question. You have to be able to identify if something is a metal, a non-metal, or a metalloid. Metals are on the left-hand side. Non-metals are on the right-hand side of your periodic table. Which is there the most of? Look at your periodic table. Is there more metals or more non-metals? Now think, metals also include your transition metals. So you have to remember that. Metalloids, remember, have some properties of metals and some properties of non-metals. And then you have to describe the groups below. Alkaline metals, highly reactive. Noble gases, another name is inert gases. Are they going to be reactive or not? Explain why. You should be able to tell me why. Let's see. You should know the properties of metals, the properties of non-metals, and the properties of metalloids. Go and review some of your notes. I made you guys do a table on that. All right, let's see. And you have to explain periodicity. Okay, that deals with the melting point and boiling point and how there's patterns in the periodic table. So that is chapter 15. Let me look at it. All right, what are good conductors? Our good conductors are going to be metals. Poor conductors are going to be our non-metals. You have to remember that. And you have to tell me why carbon is so important. Why Ms. Carball says it's the most important one, because it has its own chemistry named after it. All right, now chapter 16 is our compounds. This is our newest one. Look at your notes again. You have to know how to do the oxidation numbers. Remember, when you have a compound that is going to be neutral, that means the oxidation numbers have to add up to something. They have to add up to 0. Know how to do that. Remember, when chemical bonds are formed, something is released. You should know this. All right. Let's see. Let me go through the concepts. Oh, the concepts. The chemical formula, how to read a chemical formula, how to know how many. If you have water, you have 2 hydrogen, 1 oxygen. Remember, a chemical formula is a ratio. You need to know that. And it's about the molecular structure, and that's the shape of the compound. You should know the difference between an ionic and a covalent bond. How you can tell right away if it's an ionic bond, how you can tell right away if it's a covalent bond. Remember, ionic bonds make salts, quite hard crystals. You should know how to do the Lewis dot diagram. Lewis dot diagram is also called the electron dot diagram. You should know that. Which electrons are involved in making chemical bonds. You should know those are our valence electrons. How many do you want? It's a rule I taught you guys about a lot. Go back to your periodic table. Go back to your notes. You guys should know about elements closest to the noble gases. So that's group 17. How would you tell me what they're like? Are they non-reactive or highly reactive? How about our alkali metals? They only have one valence electron, so they're highly reactive. Look at your notes on what I put down for you guys about where the highly reactive ones are. The ones that are not reactive are kind of in the middle. You should know what a strong electron donor is. That's going to be on the left-hand side of the periodic table. The electron donors are on the left. The acceptors are on the right-hand side. Ionic compound, far apart on the periodic table. Covalent bond, close together. Ionic bond is usually between a metal and a non-metal. Okay. Review your concepts. Write things down. Don't sit in your bed and read. It's not going to help. Put it on flashcards. Talk to your family about it. If you have to keep going back to your textbook to find the answers, you don't know it yet. Good luck. And this is why Ms. Cardwell keeps telling you, read over your notes, study. See you tomorrow.